Okay, AAHL times 1 paper 2, section B. If you need section A, it's in the description. If you need to take a screenshot, check out the video on section A. Let's go. We have a function. We want it to intersect with y equal to x. That's obviously something your GDC will do for you. So it's what? IT times e to the power of negative 0.5x and also x. So plot graph. The scale is quite bad. We'll try, I guess, to make the x a little bit better. No auto. So like 0 to 20 maybe. And for the y, I don't think your calculator can do it auto, so I'll try my best to show what I would do, maybe 0 to 40. Okay, it's kind of bad because I can't really see the x-axis, but should be good enough to find the intersection. So x is 5.566. And then there's a line with gradient L1, and L is a tangent to F. We need to find Q, so we need the exact coordinate. That would mean we probably cannot use the GDC to solve for this. So we'll do it ourselves. We basically want the gradient to be -1, so we'll differentiate f. So f prime x is what, 90 times negative 0.5 e to the power of negative 0.5 x, right? Chain rule. So it's negative 45 e. That thing, and we need this to be -1. So solve x, right? Divided 45. Then what? ln both sides because of the e. ln e is 1. Then we divide the negative half. So that becomes -2 log that. 1 over 45 is 45 to the power of -1. So drop that. 2 ln 45 is x. Okay, that's the x. Let's find the y as well because they want the coordinates. We'll have to sub this into the function. So f 2 ln 45 is 90 e negative 0.5 times x, so 2 ln 45. So what? 0.5 and 2 cancel out, and then we move the negative to the top to the power of -1. We do this because then the e and log can cancel out. So times 45 to the power of -1, that's 1 over 45, so it's 2. Okay, so 2 is the y coordinate. Then we'll need to find the equation of L, so we do y equals to mx plus c, gradient is -1. We sub in the coordinate of q to find c, so c is 2 plus 2 ln 45, which means the equation of tangent is -x plus 2 ln 45 plus 2. Alright, nice and easy. Oh, in case you forgot what I said in section A, this question is shared with SL, so it really shouldn't give you any trouble. Find a point where L intersect with that line, so that's GDC time again. So we will graph that, I guess. So another graph, add another graph, negative x plus 2 ln 45 plus 2. So let's plot that. It's kind of like that. Okay, yeah. Oh, we want the intersection, right? So Which intersection do we have? Do we want L with y equal to x? So that's my calculator don't want to give me that. Does it? I think I need to move to, yeah, I want that. Is 4.8, 4.80666, okay? X coordinate. Hence find the area. So the area is a bit annoying because if you can see it, you have to cut it from here. Cut it there at P. P has X coordinate 5.566. Right, and this was what we just found, the 4.8 thing. And this Q, the 2ln45. Alright, and so you need to find this left bit and the right bit separately, because the left bit is formed by y equal to x and L, while the right bit is formed by the curve and L. Alright, so for the left bit, if you do upper curve minus lower curve, the upper curve would be x minus L. L is negative x plus 2 ln 45 plus 2. And you integrate from the intersection 4.80666 to 5.566, I think. Yeah. Okay, that's the left. Plus the right hand side part, alright, which is 5.566 to 2 ln 45. Right, the x was 2 ln 45 for Q, and then upper curve is the F, which is 90 e negative 0.5x minus the bottom curve, which is L. So it's this. So obviously you don't need to actually integrate anything by yourself. You just type this whole thing to your GDC, and whatever value you get is the answer. So I'm really not in the mood of typing, so you can try that. Then I believe the question is not ended yet. Then they added the inverse of f, and now find this whole region. For some reason the line of y equal to x is missing, but we know it sort of goes through like this. Right, we know that because the inverse of f is the reflection of f along the line y equal to x. So I have to go through like that. And then you can probably see that this green area is the area that we just found, right? Look the same, right? The whole thing, the green would be now the whole thing. Alright, and so this whole area would just be whatever we found in part D, and then times 2, because they're simply reflection of each other. Yeah, not bad, right? It's kind of tricky for SL, but hopefully it's not a problem to you. Next one we have question 11. Find P and Q. P and Q are here, so P and Q are actually like the value that cannot occur in the domain. So we know for a fraction the bottom cannot be 0. So we consider what happened if that is 0. We have x squared is 1 over 4. So x would be plus or minus half. That means P and Q would be half and minus half, right? Because x cannot be half or minus half. Then they look for the derivative, simple quotient rule. So hopefully you won't need me to show you much. Quotient rule minus differentiate the bottom 8x times 3x plus 2 over the whole thing. So it's 12x squared minus 3 minus 24x squared minus 16x over the bottom. Usually for quotient rule we never, usually we don't expand the bottom. It's almost always useless to expand the bottom. The top we usually expand though, because they can usually simplify. 12x squared minus 12x squared minus 24x squared, so minus 12x squared minus 16x minus 3. Okay, and then what? They want a point of inflection. So, point of inflection, how do you find it, right? It's probably that the second derivative is 0. Second derivative is 0. Right, so one way would be you differentiate this again and then solve that equal to 0. But in case you think differentiating this again would be too much work, I would agree with you. So another way would be, if the second derivative need to be 0, then it would mean that the derivative of the first derivative would be 0, which means the first derivative should be at a maximum or minimum. Right, so another way to locate the point of inflection of the original graph would be plotting the graph of the derivative and then look for maximum and minimum. At least that's a viable thing to do in paper 2, because we can graph, so we'll be graphing. So I will have to clear them all. Right, negative 12x squared minus 16x minus 3 divides 4x squared minus 1 squared. Okay, let's see. What is the domain? Domain is anything, right? So I might want to zoom out a bit, I guess. So let's zoom out a bit. So we have more negative, and then y also go more y as well. Okay, so we can see there are vertical asymptotes at negative half and positive half, which is reasonable, but I don't see any maximum or minimum. So it's probably because we zoom out too much, so we can't see where the maximum and minimum are, but I'm hoping they can find it. Where is it? Is there a maximum? Is that negative 0.5? What about minimum? Okay, let's say it's around that region, around negative 1.5 something. So let's zoom in there, see if we can actually see. So x probably don't need to be that much. And y also don't need to be that much. Still, we can't see much. So let's go negative 2 to 2. And y would be negative 5 and 5. Cut that in half, right? Do we see something? I think that this is a minimum. Like this is a minimum. You can kind of see it go down a little bit and then get closer to the x-axis again. So I think that's why there's a minimum. But there's probably no maximum point. Alright, if we already have a minimum. So the x coordinate of the point of inflection would be at the x coordinate of the minimum of the derivative. And then it says sketch the graph of f. Well, that's not very interesting because we can just graph that, right? Let's keep the derivative in case we'll need it. 2x plus 2 divide 4x squared minus 1. So plot. Now this time they say they want x to be between -3 to 3, so we'll use that as our range. And make y bigger as well, I guess. Is the red one for this case. So I'll need to include all the intercept, local maximum, minimum, and asymptote. Alright. So first, negative half is a vertical asymptote, and half is a vertical asymptote as well. A horizontal asymptote would be y being 0, because for f, the denominator have a higher power than the top. That means y equals 0 is a horizontal asymptote. And then we'll need to find the maximum. So maximum, whoa, what's going on? What's the other one? That's the one that I want. It is at, so remember the shape was something like this. This point with the maximum is negative 0.226, negative 1.66. I will need the y-intercept as well, so we'll find, wait, how do we get, well, they'll only give me the x-intercept, so go down, go, no, I don't want a yellow graph. Wait, can I get the, yeah, this is -2, when x is 0, y is -2. Can I get the intercept of the red graph though? Okay, let's go to the red graph and then find the zeros. So it's like this. So this is negative 0.6666. That looks like 2 over 3. And then we had a point of inflection, right, at negative 1.5. So that's about here. This is negative 1.595. Right. Okay, they didn't ask for drawing the point of intersection, just maximum, minimum, and intercepts. So I have the x-intercept, I have the maximum, I have the y-intercept. There should be a minimum, right? This is asymptote, this part here. Like, this is asymptote, okay. So there should be a minimum about here. So let's find that. So okay, fine, minimum. So it is given as negative 1.11, negative 0.339. Okay, and then the other side, this should just go down to the asymptote, so no maximum, no minimum on that side. That would be my sketch. Okay. And then what? Now we have another function Are they related? They just flipped. Find the asymptote. So first we have the vertical, which is when the bottom is 0, so x equal to -2/3. But now the top power is higher than the bottom power. That would mean we'll have a horizontal asymptote or oblique asymptote. To find it, the best way is doing long division. Then the quotient, I mean the answer of the division would be the oblique asymptote. So we have what? 3x times what give you 4x squared, so it's 4/3x. Right, when 3x times that give you 4x squared plus 8/3x. Subtract negative 8/3x minus 1. So then we have 3 times what is -8/3? Negative 8/9, right? So that will give me -8/3x minus 16/9. Then there will be some remainder, but we technically don't care about the remainder because it's just top that gives me the oblique asymptote for this. And then they tell us to solve fx minus gx, and they already tell you the method. Just graph gx minus fx. Right, so this is a pretty dumb question overall. It's just a waste of time, we're time consuming to plot everything and blah blah blah. So 1 gx minus fx, so I guess I'll just edit this. So gx is the bottom one, so it is 4x squared minus 1 over, not like that, minus over 3x plus 2, like that, plot. Now we want fx to be less than gx. That would mean gx minus fx is bigger than 0. So we want a part of the graph that is bigger than 0. So we will need the x-intercepts. So find zeros. The one there. Alright, let me like roughly draw the graph. There's a vertical asymptote at -2/3, and then the right hand side look like this, and then we have where's the asymptote? Why do I feel like graph is so weird? Why do it look like there are two different vertical asymptotes? I mean, if you can see, this is the oblique one. This here is the oblique one, but the vertical asymptote look odd. Maybe I can zoom out a bit to see what's going on. So let y go bigger, negative, I don't know. Let's see. Oh, right, because I'm graphing both gx and fx, so there's actually 3 vertical asymptotes. Alright, so the one that is smaller is -half, which come from f, and then the graph go like this, and then you have another vertical asymptote which come from g, which is -2/3. Right, that's more negative than a half, so it's on the right, on the left, and then you have a graph that look like this, and then you have this vertical asymptote which is half, which come from f, then the graph look like this, right? Then we found this point to be -0.569, and this point is 1.319, right? 19. So again, we want the graph to be bigger than 0. So it would basically be this part, and this part. therefore the answer is x is between negative 2 over 3 to negative 0.59569, or x is between negative half to half, or x is bigger than 1.319. Alright, for that three pieces of the graph. Yeah, a pretty annoying question, but probably not too hard. So question 12 looks like a differential equation question. Right, they give you a differential equation, they want you to solve it, and then once you have found the equation of P, you can answer questions about P, the population. Alright, the first part of A and B should be there to help you to solve the differential equation. Part A, they want you to rewrite the derivative, which is 1 over x k minus x, into this. So this technique is known as partial fraction. So I guess most people do it like get a common denominator on the right. So it's x k minus x. So A need to times k minus x, B need to times x equal to the original thing. That would imply 1 have to equal to the numerator of the right hand side. Here most people like sub in values that they like. So if you sub x to be 0, you can do this because the A and B is supposed to work for any value of x. So you're allowed to sub in any value of x. So if x is 0, the left hand side is 1, the right hand side is ka. We're assuming k is a number, so we can find a in terms of k. But then you can sub x to be k because k is just a number. Then this is 0. You have b times k, so b is also 1 over k. Okay, so both a and b are 1 over k. And so they want you to find fx, so that basically means integrate f prime x. So you integrate 1 over x, k minus x. The method would be you break it into these two fractions. So it is 1 over k over x plus 1 over k, k minus x. Then each of them should be readily integrable, right, as log. So it is ln x minus ln k minus x. It's a minus because of the negative in front of the x of the inside. Technically I should put absolute values, plus c, close the bracket, plus c. Okay, so that's fx. Usually we find a c, but for this question they didn't give us any information. Again, it's only there to help you solve the differential equation, so that doesn't really matter. So there's a population of ants. Initially 1,200. They want us to, they give us the differential equation about the population. So we obviously want to solve the differential equation. So there are types, right, of differential equation. You probably should know 3 types in IB: separating variable, integrating factor, and homogeneous. This is obviously separating variable, right? So you multiply the dt to the right, and you divide all the p stuff to the left. So it's 1 over p k minus p dp equals to 1 over 5k dt. Then you integrate. So this is where part B was useful. This is basically done as this, except now instead of x, that becomes p, so it's 1 over k ln p minus ln k minus p, okay, plus c. But usually if you have two integral, one on the left, one on the right, you only add c once. I personally add it on the right. So integrate 1 over 5k dt. Remember k is a constant, so if you integrate this, you get a t plus c. Now the idea is you should use this information to find one of the constant. You should be able to either find k or c. I think we'll be able to find c like that. So initial means t is 0. So when t is 0, p should be 1200. So if we put that in, we get what? 1 over k log 1200 minus log k minus 1200 equals to t is 0 equal to c. Now let's simplify this a little bit. We have log minus log, so that's log divide. Alright, still absoluted. Equal to c, so c is that thing. Then we'll put the c back into the c, and we're supposed to make p the subject. Alright, so as far as differential equation question goes, this is quite common. But I guess if this is the first time you've seen something like this, then it can look quite complicated. Alright, so let's go through the process. We have to move all the log to one side. Alright, so we minus that. While we do that, we'll also take out the 1 over k. There's 1 over k. And then here we do the similar stuff. We make it divide. That minus the other log. Equal to 1 over 5 kt. Then again we have a log minus another log. So we can again divide them. So it becomes p times k minus 1200 over k minus p times 1200. Right, because we're dividing, so we flip the second fraction. 5kt. I think this k cancel out. And then we can get rid of the log, the ln, using e. So it's e to the power of 50. So let's check if that's correct. So they do have e to the power of 50. You may be thinking they have negative though. That's fine. We can make the negative appear later. Let's p 1200. Then we have to multiply the bottom to the right. And yeah, let's keep this. Kt times 1200, so multiply by 1200 e 50. We expand the k minus p, so it's that much k minus that much p. We expand because we want to move all the p to the left hand side, and then factor the p out, so it's k minus 1200 plus 1200 e 50. That equals to 1500 e 50 k. Then p is really 1200 e 50 k over that. Okay, when you look at the final answer, does it look like that? Yeah, pretty much. Again, I said we'll make the negative powers come up, right? The way to do it is you divide both the top and bottom by e to the power of 50. So this needs to divide e to the power of 50. This also needs to divide e to the power of 50. But when you do that, this cancel with this cancel out with this. While here, if you're dividing by e to the power of 50, that's the same as multiplying e to the power of negative 50. So we add that 1200, and the top have 1200k left. So that should look exactly what they have there. Yeah, I think so. So yeah, that's the common simplifying process. Alright, then the question is, when t is 10, the colony would double 5k, so that means when t is 10, it should be 2400 for p. So is that c? I think it's ci. So when t is 10, the p is 2400, so we just substitute it to here. 1200 k over k minus that e 10, a fifth times 10 is what? 2? Negative 2. Negative 2. Well, it's paper 2, right? We have GDC, right? We'll probably multiply the bottom to the right. So it becomes 2400 e negative 2k minus, I'm expanding, so that's what? 2400 times 1200? Oh, wow. 0, 0, 0, 0, e negative 2 plus 2400 times this 120, 1020 as well, 1200, you know. But that equals to 1200k. So we move the k to the left. It's 1200 k minus 2400 e negative 2k. Equal to the left hand side. And so we factor out the k and divide. Okay, what do we got? We have negative 2880000 times e to the power of negative 2 plus 2880000 on the left, divided by 1200 minus 2400 times e to the power of negative 2. Giving me what? 2845.34. Wow. We want what? 4 significant figures. So 2845. Wow. Hope I get it right. And then lastly, find a t so that the rate of change is maximum. Oh, this could be quite a lot of work. They want the rate of change, so they actually we actually need to plot dp dt. But I don't think I want to differentiate this. Right, it's kind of huge. The other way would be using this, right? Because dp dt is given here, it's a differential equation. So you can also put in the answer you found into the p, and then graph that. But that would also be quite a lot of work, into typing into the GDC. So I guess the easiest way would be I just graph p and then ask the calculator to graph the derivative of p. For most calculator, that should be possible. Alright, k was what? 2845, right? So if I graph p, 2845 divided by 2845 minus 1200 times e to the power of negative x over 5 plus, no, not there, plus 1200. So that's p. Find in your calculator how do you type derivative. Okay, it seems that for my calculator I can do it like this. I can find the derivative symbol And I actually put in the whole population, so differentiate the whole population, and then tell my calculator to plot it. For TI, you can actually TI Inspire. You can actually in the graphing thing type differentiate, which is the button to the left of the book. On the right top corner of the number pad, there should be a book symbol, and then to the left, if you click that button, uh, you can find the derivative sign. And then if your p was put into like the first function, it should be f1x, right? So you can say differentiate f1x, then he'll plot you the derivative of the first function you put in. If you're using Casio, though, I'm not too familiar, so you need to figure that out. But I totally think it should be possible. So adjust the window a little bit. I think x. So what? Y is double in 10, maybe 100. And for y, I'm not sure how the range would range from population go up to like thousands. I don't know, maybe 5,000. So there's, I think the red one is the population. Where is my derivative? Oh, there. What's the maximum of that? So I need the maximum is 1.577. Oh, that's kind of small. But it kind of makes sense that this is basically, this is called Logistic model. So it makes sense that the rate of change is the maximum when it's about this point. You can see, right, at this moment the gradient is steepest, right? So it makes sense that at that time the rate of change of the population is maximum. Alright, it's just a bit small to my surprise. Okay, so it's basically 1.58. Okay. So that should be it for Times 1 Paper 2. If you have watched my solution on Paper 1, I did say Paper 1 seems a bit too easy. I have to admit Paper 2 is harder than Paper 1, so all in all, I think it's kind of fair. This question 8, 9, kind of tricky. 6 is also a little bit tricky. And then the last two long questions seems to be quite time consuming if you don't know exactly what you should do. So on the other hand, they are not like super tricky, that kind of stuff. But I do think overall, Times 1 is a solid Excel papers. So yeah, stay tuned. Hopefully you get subscribed, and because more solution videos should be coming for both Excel and SL. See you there.